All right. Welcome to our notes today. Whether or not you took the test retake or not, you should be doing these notes on Wednesday, either during class or at home. So we're going to be going over just the first half of 13.2, just as an introduction to some of the stuff that we need to do for rational functions. We'll review these in class on Thursday and talk about some more complex stuff with rational functions on Thursday, and we'll have a quiz on Friday that covers 12.1, 12.2, and 13.1. So let's get started at looking at our book. So we're on page 171, 13.2. Our learning targets are going to be determine the horizontal, vertical, and oblique asymptotes. We're not really going to talk about it too much. We'll focus on just horizontal and vertical. We're going to accurately graph rational functions, and that means without a calculator. We'll talk about how to look at the function and make some graphs. And then we'll talk about a little bit how to solve rational equations. Solve rational inequalities, but that will most be a lot more of 13.3. So this is what we just finished talking about. If we have a rational function in this form, but that means we only have x by itself with the power of 1 and no x's on the top, that's not going to be that often. So if we look at number 1 right away, we have an equation that does not look like the form above. There is no a, the x is squared on the bottom, there's nothing we can do. So let's try to graph this real fast, and I hope that I still have Desmos open. No, I don't. So let me find Desmos real fast. All right. We had to graph the function x minus 5. We are graphing this function, x plus 5 on top, and then x squared minus 4 on the bottom. So here, if this inequality, we have a funky looking one that has more than one vertical asymptote like we saw the other day, and we have a horizontal asymptote as well. So we need to talk about how we can see all this stuff in our function. So the book asks, use your graphing calculator to graph this function. How does this graph differ from the graphs of our other rational functions? I already kind of said it out loud, so let's go back to our notes. It has two vertical asymptotes, exclamation mark. And if we remember those were at plus and minus 2. And if we actually look at our graph, we do have a x-intercept that we can barely see at negative 5. All right. So we haven't really seen much of those. So now what's asking us to do next is to forget that we saw that function and graph some other ones so we can try to see what's starting to happen. So let's get rid of that. It says we want to graph 2x plus 1 as our numerator, x squared minus 1 as our denominator. Ooh, look at that funky graph. And then another rational function where we have 7x squared minus 3. And then we have 5x to the 4th plus 1. And oh my gosh, it keeps getting weirder and weirder. So we're looking for patterns to complete the statements below. We want to make a conjecture about how to find the horizontal asymptote for a rational function where the degree of the denominator aka the bottom, is greater than the degree of the numerator. So let's zoom out and see if these things have anything in common. We're zooming out, we're zooming out, we're zooming out. So even though the middle of the graph looks weird, both of them still have a horizontal asymptote at x equals 0. But when we zoom in, the middles look very different. So let's go back to our notes. Both of these have a horizontal asymptote of y equals 0, but why? And it's exactly what the book said. When the degree on the top is is less than the degree of the bottom, we will get a horizontal asymptote of y equals 0. That will always happen. So we can even check that, which is B is asking us to do. So you guys can come up with your own. I'm just going to start typing stuff. We want the degree of the bottom to be bigger. So I'm just going to use my birthday. So 5x to the third plus 1. And then that's my month and day. Let's try my year next. So we're going to do 1x to the 8 plus, to the 9 plus, and then 8x plus 9. So no matter what I do, the degree on the bottom is bigger than the degree on the top. So when we zoom out, that purple line is still going to have that horizontal asymptote of 0. No matter what you do, as long as the degree on the top is less than the degree on the bottom, then we will have a horizontal asymptote of 0. All right, so we're going to add this to our rational function notes at the end of this video. All right, next one, number 3. Now we have where our degrees of the top and the bottom, right here we have degree 1, here we have degree 2, our degrees match. So let's see what happens here. It's going to be a little bit more complicated. All right, so let's go back to Desmos. Let's get rid of all this hard work we've been doing in your graphing calculator. If you're following along, this must be kind of frustrating because it takes so much longer to type in there than on Desmos. And then we have 2x squared plus 3, and we have 2x squared minus 3. So in these two cases here, we have some horizontal asymptotes. They're not the same, and we need to figure out how do they get these numbers. So if we look at the black curve first, we have this horizontal asymptote, right? No matter how far we go to the left or the right, it's going to start looking like a horizontal line, and that's going to be at y equals 6. So let's go back and look at our function. All right. For this function right here, we will have a horizontal asymptote of y equals 6. We need to try to figure out where in our function do we see any numbers that would kind of give us a clue that our horizontal asymptote should be 6. So let's think about that as we now try to figure out the horizontal asymptote of the other one. So let's go back to our Desmos. Let's look at our red curve now. Here we have this new curve, and if we go left to the right, it looks like we have a horizontal asymptote at y equals 1. So we need to look at this. What can I do to get these numbers? If I look at the first one, I see a 6 right here. So maybe it's just the coefficient on the numerator. But if I look on the second function, that's a 2, and that's not our horizontal asymptote. So we are looking at this, we're trying to figure it out, and hopefully you guys have already been thinking about it, and I'm just the late one in the group. But what we have to do, we have to take if degrees match, then we divide the leading coefficient of the top by the leading coefficient of the bottom, right? So in this case here, we did 6 divided by 1 to get 6. And here we did 2 divided by 2 to get 1. That will always work. So again, B for this problem says, let's try to test that. So I wish I didn't delete the other thing, because then I could have just changed some numbers. So let's try another rational function that I just make off the top of my head. We want the degrees to match. Let's just do 6x third plus 2x plus 10. Just making it up. Next one, we want our degrees to match. Let's try 2x to the third. Our degrees have to match, but we can make this a funky one. Plus 4. Oh, let's do a minus. Minus 4x squared. So if our rule is correct, our conjecture, we take the leading coefficients of our top and bottom because we have the same degree and divide them. So 6 divided by 2 is 3. Let's check it. Does our horizontal asymptote end up looking like y equals 3? And that is correct. Yes. Let's try this out though. What if I change the leading coefficient on the bottom to 3? So 6 divided by 3 is 2. Does that now work? Yes. And we can keep playing around to see if this is going to hold true. Let's try 12. 12 divided by 3 is 4. If we look at the left or the right, our horizontal asymptote is now 4. So it seems to be working even if we have negatives here. All right. 12 divided by negative 3 is negative 4. And if we go far enough to the right or to the left, we'll get a horizontal asymptote at y equals negative 4. All right, so this holds true. How exciting. All right, so now we've talked about if the degree is bigger in the bottom, if our degrees match, and it seems to me that the book kind of glosses over if the degree on the bottom is bigger. And I can't remember if we talked about this other days in class, but let's say we look at one where the degree of the top is bigger than the degree of the bottom. So an example of that would be a simple one. Let's just do x to the 6 plus 2 over x to the second minus 5. Again, this is just something I made up for us to test this. So x to the 6, and I said plus 2. And then we have x squared minus 5 on the bottom. So this really doesn't look like a rational function, right? It just looks kind of like a weird parabola. So if we keep trying this, this will be, if the degree on the top, our general rule is there are no horizontal asymptotes. All right. So our end behavior would just be it goes to either positive or negative infinity. We'll talk about maybe when that might have some exceptions, but for now we're really focusing on what the book said was where our degree on the top is less than the degree on the bottom and where our degrees match. All right, so let's move on in our book. Number 4. All right, we want to find the y-intercepts, which would be where any of these curves, right, cross the y-axis. And that's at x equals 0. So all we have to do is plug in 0 into our functions. So we're just going to do one example, and let's just do the one that I can still see on the screen. So we have 6x plus 1 divided by x minus 1. That's our function. We want to find the y-intercept, so we have to plug in 0. So we get 6 times 0, which is 0 plus 1, so 1. 0 minus 1 is negative 1. We can simplify that to negative 1. So this function would have a y-intercept of negative 1. It's not really that difficult for these, right? We just plug in 0 into our function. The x-intercepts is more difficult, right? Our x-intercepts is where our curves cross the x-axis, and that's when our numerator is 0. So we need to figure out where is the numerator equal to 0. So we actually need to just take the numerator. So for example, for function u, we would take 6x plus 1 and set it equal to 0. So we would minus 1, 6x equals negative 1, so x equals negative 1, 6. And this is our x-intercept. If we do that for v of u, we have 2x squared plus 3 equals 0. We still try to solve this. But then when we get to this point, we have to take the square root. We get a complex number. So we can say no real x-intercepts. All right. So we need to be aware that that does happen. We can have x-intercepts, sometimes we can't. Just like if we have a vertical asymptote at the y-axis, we might not have any y-intercepts. So we'll look at more examples in class on Thursday of this. I'll probably give you a worksheet, not bookwork, just so we can walk through some stuff. So let's move on to the next page. It's asking, what relationship does the numerator of a rational function have to the zeros of the rational function? We already said this. I guess they just wanted us to graph it. Where the numerator is equal to 0, that's where we get our x-intercepts. All right, so the next part of the book is going to have you just find these things, right? The intercepts, the horizontal asymptote, the vertical asymptote. What our behavior is doing, and then also what our window should look like. So let's, at this point, make a new page. There we go. Ooh, that's huge. Okay. So we have our rational function notes. Right? We have a whole bunch of stuff in here for where our rational function looks precisely like this. But that's not that frequent. So we need to make one for messier rational functions. And this one we're going to use way more often, all right? First thing that we usually talk about, okay, is y-intercepts. And what we need to do is plug in x equals 0 and solve. That's how we find our y-intercepts. For our x-intercepts, we need to set the numerator, which we also call the top of the fraction, equal to 0, and solve for x. And maybe let's come up here and change the solve for y. All right, we have the two types of intercepts. Next one, we need to talk about vertical asymptotes. And what we need to do there is set the denominator equal to 0. All right, and solve for x. And that will tell us where we have vertical asymptotes and where we have issues in the domain. The next one, and I'm going to do it off on the side, is our horizontal asymptotes. Wait, down here for vertical, let's remind ourselves it's going to be x equals a number. Vertical is always x equals a number. Horizontal asymptotes. All right, that one has a lot more nuances to it. So we have our first case. If the degree of the top is greater than the degree of the bottom, that's going to tell us there are no horizontal asymptotes. If our degree of the top is less than the degree of the bottom, the horizontal asymptote is y, that looks like a G, y equals 0. And then the trickiest case is where the degree on the top is equal to the degree of the bottom. We have to do, and I'm going to have some more space. The horizontal asymptote is the leading coefficient of the top divided by the leading coefficient of the bottom. And all right, and we're going to do a little note. LC stands for leading coefficient. All right, so those are our notes for our messy rational functions. Unlike up here where we just said A is the vertical stretch, B is the horizontal compression, C divided by B is the horizontal asymptote. No, I'm sorry, horizontal shift, and D is the vertical shift. We have a lot more complexity with our messy rational functions. So let's try to practice this in our book. All right. So they kind of gave us one that was already solved, and those are no fun. You can walk through that yourself. But let's try to do one on the next page. So I think that's page 173. All right. So if we, sorry about this. If we look at the try these A, before we get started, let's try to factor the bottom. So we would love it if it factored up good. We want two numbers that multiply up to -15 but add up to -2. There'll be x minus 5 and x plus 3. So now we can kind of see things a bit more clearly. We're not too worried about it. So first thing, let's find the y-intercept, which means plug in 0. So we get 0 on the top, and then we get 0 minus 5, 0 plus 3. So that would be 0 times -5 over 3. So 0 over -15. So 0. So our y-intercept will go through 0. Our x-intercepts, what we need to do is say, and I'm already kind of blanking because it's kind of late at night. Let's check our notes. We said x-intercepts, set the number on the top equal to 0. All right, so number on the top is x. So we do x equals 0, nothing else to solve. And again, x is equal to 0. So next one, we can find our vertical asymptotes. All right, we set the numerator equal to 0. There's a lot of setting stuff equal to 0 here, right? 0 is a very important number in pre-calc. So then we have x minus 5 is equal to 0 and x plus 3 is equal to 0. So then we get x is equal to positive 5 and x is equal to -3. So here we have a vertical asymptote. And then -3, we have another vertical asymptote. All right, we still don't know how to draw this yet. We have one more thing to figure out, which is the horizontal asymptote. That's our new one today. We check the degrees. The degree on the top is smaller than the degree on the bottom. So that means we're going to have a horizontal asymptote at x equals 0. So we want to graph this, and we're still not using our graphing calculator. So what we need to do is just figure out where our function exists. So it could be like this, or it could be like this. We don't know. To check, we just need to see what side of our asymptotes our stuff is on. So we just need to pick a number. Let's just say -5, right? We plug in it, we get -5 on the top, and then we do -5 minus 5, -5 plus 3. We just really care if it's negative or positive here. So -5 is on the top, -10, -2. So we'll have negative times a negative on the bottom, negative on the top. So we have a negative answer. So we can just try to estimate it. I'm going to change color here so we can see it better. All right, so that's what our curve is going to look like. All right. Next, let's pick some point. We know it has to go through here, but we don't know if it's going to look like this or like this. We know it crosses the x-axis only once there, so it has to be one of those two options. So let's try to figure out. I like the number 1. That just seems easy to me. So we have 1 on top, and then we could either plug it into the non-factored or factored. I'm just going to keep with the factored idea. So then we get 1 on top, -4 on the bottom, times +4. So we'll get a very small but negative number. So it'll be like this, which means it'll come down, go through here, and then come back down. All right, and then lastly, we have to pick something over here. 6 is the only one I can kind of see, so let's try 6 out. So we have 6 over, and then we do 6 minus 5, 6 plus 3, so we get 6, 1, 9. Again, we don't care what it is, we just care that it is positive, so which means it'll come down and then still have that horizontal asymptote, right? So what we need to remember is it won't cross that horizontal asymptote no matter how far to the right it goes or to the left. The center is its own separate thing. But at the end behavior, it'll have the horizontal asymptote of x equals 0. So I think what I'm going to have you do is try B on your own. And we'll do that as our do now on Thursday. So that way you can just open it up, check your work with your neighbor, and see if you need to fix anything based on your comparisons. All right, so hopefully these notes made sense. Hopefully I know some people were frustrated that we didn't have anything for horizontal asymptote yet. So hopefully this all made sense. Some of you guys were saying that you guys learned this already in Algebra 2, but hopefully we cover stuff a little bit more intensely in pre-calc. All right, good luck.